View page curriculum. I need this, don't I? What are you doing? All right. What are you doing with that?
I'm gonna check the logo.
All right. So continuing off from last week, just do a little recap. So we started off with Node.js. We went over how the server clients work together. How do they interact? We discussed very briefly what RESTful APIs are. We talked about some commands like put, post, delete, get. And we talked about CRUD, which are different ways you interact with, I guess, data that you make on your server. You create data, you read data, you update it, and you delete it. So we set up a basic skeleton of an Express application, and we created a basic API route, our first one for our event application. If you remember when you accessed this route, I think it just said events, just some text showed up. Does everyone have their server running right now? Is it still working when you go to the events route? That's why. Just maybe smaller. Okay, so before we move forward, when we started with our Express skeleton and made a lot of extra code and folders in our project directory that we don't need. So right now we're just going to go ahead and delete some of the folders. The first one we're going to delete is the public folder. Because we're not building a website, we're not serving up images or style sheets or JavaScript files right now. So just to keep it clean while we get started and move forward, we're going to delete the public folder. And we're also going to delete the views folder. So if you guys remember, when we first started and we started our Express application, we went to localhost 3000. It said Express or welcome to Express, and then we changed that. And what that was doing is, as soon as you went to localhost 3000, Express was rendering a template. It's a viewing template that you could fill in. And we went over filling it with variables last time. Like Express was a variable we passed into the template. And now that we're removing all the views and the public folder, all the front end web stuff, we also want to remove anything that requires it, anyone that's dependent on those templates or anyone that expects those templates to be there. So if we head over to our app.js file, which is our main server file, we want to remove the following lines. So the first line, app.setViews, tells Express where can it find all your view templates. So when you tell it to render a view, where's Express going to go look? And app.setViewEngine tells Express what language the template was in. So sometimes you have templates in HTML. In this case, Express set it up with a language called Jade. So we're going to remove those two lines. And we're also going to remove the lines with app.use favicon and app.use express static. Static files that usually are found in the public folder are files that don't change over time. It's like your logos and your banners for your website. So we don't need that for us since we're building an API to talk to a web application and a mobile application. And favicon is that small little like square picture that shows up on your browser on the top of your tabs, but we don't need that. Is everyone good? Cool. Now, if you look into your app.js file, you'll see there's a lot of code in there. Give me one moment. Let me open up this. it. So I'll do the same stuff. We're going to remove these files. We're going to remove this one. And then we said to remove favicon, which is already gone. Give me one moment. So now if you notice, there's a lot over here which says catch 404, forward to next handler, error handlers. And what these do are whenever Express encounters an error, or there's some route that doesn't give back data or didn't function the way it expected, it's passed down Express, and Express has these handlers which say, when I'm given an error, how do I respond? What do I do? So first one over here we see is app.use function request response next. That's what REQ, RES means. And we're going to see this all over the place in our code. And these are called request handlers. And you're given a request that comes in over here. And there's a response object over here. The response is what you're going to interact with when you want to send something back to your client or whoever made the request. And there's a next object. Next, what this tells Express is when you pass next an error, it's going to take that error and bump it to the next handler in line. So as you can see, over here we have app.use function request response next. So if somehow there's a request that makes its way to this handler, we're going to create a new error object. We're going to set its status. 404 means not found in HTTP status codes. And then once we've created this new error, we're going to pass it on to the next handler. In this case, we have a handler over here in development mode. The reason there's two over here, one says development and one says production. Production code means it's used by real clients. It's out in the wild. If you notice the one difference here, the error object is missing in production. The reason we do this is sometimes our error can include a call stack. So all the methods that are being called and can give insight into our infrastructure and how our code works. So in the wild, we don't want random citizens seeing this. So we take that away. And as you can see, after app.use, the 404, we hit next. And what Express does, the order of these handlers matters. So if we go back, we start our Express application here. We first told Express to use whatever routing file this was, or router, anytime it hits the backslash. So someone goes localhost 3000 backslash, it's going to go to the router that's defined by this variable. Is this? Oh yeah, there it is. If they see backslash users, it's going to go to the router defined by users. Backslash events, like we made, it's going to go to our event router that we made over here. And then if we were to go over here and instead of saying response.send, we were to call next, that means the client who made the request wouldn't get a response from here. It would get passed down to this handler. So Express goes in order until there's a response.send, until a direct response is sent to the client and not down the stack. Does that make sense? Cool. So because these are all errors, we can move them into another function or another file just to keep them all together since they all handle one part of the code. All right, so what we're going to do is, if you look at your slides under housekeeping, we're going to move all the error handling code from the app.js file into a new file called errors.js. This file we're going to create in our project root directory, so right beside app.js. We can just copy this code in.
The slides are available on the Facebook group.
A bit. So one thing you'll notice with a lot of our files we've seen so far is this first line, or this line is commonly found, called module.exports. What this does is when you go into, say, your app.js and you see something like require, when you require a file, it's going to look for that module.exports, and that's what's going to be saved into your variable. So in our routes file and the events file that we created, we see module.exports router. This router has our handlers for the different endpoints, only one right now. But in our app.js, when we say require this events file, this variable now holds that router that we said module.exports. So in the next line, we have app.use /events, and we pass in that router. Does that make sense? How that require feature works in module.exports? So now that we've created this error file, or errors, that's going to handle all our different error cases, we'll save this. And we'll go back to our app.js, and we're going to delete all this error code, because now we're going to put it all in one place. We're going to do this. So what this line does, the var error handler equals require errors.js parentheses app. If we remember from what we just did, module.exports is equaling or returning a function. When we require that file, we can pretend that error handler is now a function. Something we can do in JavaScript is we can call the function right away. So if we remember the files or the lines we just deleted from the app.js, all the error handlers, they require the use of app. So we need to pass that back in. And that's why we made this as a function, and we didn't just copy the code over, because that same express application that we started in our app.js file wouldn't be available here. By making it a function and calling it with your express app, it's now available, and your error handlers will be called when there's an error. Has everyone made the errors file and deleted? And go back here. And what we can do is we can clean up our app.js, since we're going to be doing a lot of work here. Okay. Does everyone want to try restarting their server and just make sure everything is still working? Mainly your events route. So we're going to go check ours. It's npm start.
Did you increase my font size?
Yep.
Should increase it more.
Should I?
Yeah.
Oh, shoot. Can I open up a new window? Okay, so let's check it out. Cool. So that still works, which is good for us. Is that clear? The font? Yeah, sure. So the error.js file is the one on slide 5. So all the code in slide 5 is what your error.js file will have.
The slides are available on the Facebook group. The
But here it is.
2015 cohort one.
Is anyone having any issues with it, or?
Yeah, I'm having an issue. Oh, it was working a minute ago. That's saying, so one thing you'll notice is that we declared all this stuff first. This is telling ours and parse quantities. So we want to move this to right over here. So after all this happened, so give it a chance to be able to hit those routes in terms of ordering hours. So we want it to try going to this router, try going to the users router, try going to the events router. If all those fail, then it's going to say, hey, do I have any other handlers that can take this? And it's going to hit that. So you have to restart the server. Oh, because
You didn't save it yet. You saved it? I don't know exactly where your app.js is.
because it was off.
Yeah.
Refresh.
Okay.
So does everyone have their errors.js working? Your servers are still up and running? And your app.js file should look something like this. All right, so if you remember, every time we've been making changes to our application, we've had to shut down the server and restart it, which can become a pain in the ass. So what we're going to do is install a little tool called NodeMon that is going to watch for changes in your code base. And whenever it sees a change happen, it's going to restart our server for us. So the command is over here. It's on the slides, npm install -g. And if you remember, the -g argument is to say install this package globally. Has everyone been able to install it with npm? So after you've installed it, what we're going to do is create a file that NodeMon can call every time it wants to restart our server. So what we're going to do is we're right beside app.js, errors.js, we're going to make another file called start.js. And in this start file, we're just going to require bin/www. And why we're doing this is when you type npm start, that's basically a startup script. It's telling npm to go and look for a way to start up our application. And if you remember our package.json, which is what defines our project, what holds all the dependencies, there is a scripts key over here. And in it, it says start. And when you say npm, because npm looks in this file, and you say npm start, it's going to run this command, node, which is our node server we talked about, and .bin www. We haven't really looked into this file much, but this is just some server configuration stuff, telling it what port to use, if it's an HTTP server or a different kind of server you can have. We don't have to worry about it too much, but all we need to know is that when we hit npm start, it's telling node to go start this file. And now we want to use a tool to help restart our server every time it sees a file change. So by creating the start.js file and telling it to require .bin www, the // means in the current directory. So we have start in the directory, we go up, there's bin www. What this does is, if node is starting that file, we now want this new package called nodemon to start that file whenever it restarts the server. So now that we have nodemon installed and we have a new start file, let's give it a shot. Here we see nodemon is started. Let's double check our server. Oh, goddamn. Server is still up and running. Server is good. And let's see if it actually restarts when we do a change. So we hit save, and the server is updated. So events updated, I'll hit save, go back, and it works. So this saves us a lot of hassle or forgetting to shut down the server or restart the server every time we make a change.
Scroll up to see the error message.
Is nodemon working for everyone?
Did you save? Oh, it's npm start.
The start.js is just a way to kickstart our server. So like we said in package.json, there has a little object that says scripts and start. And in it you see node.www or bin www, which is every time you hit npm start, it's calling that command, which is node bin www. So now we have another piece of software in our stack, which is listening for changes. So anytime we make any text changes to a JavaScript file in this folder, we need to give a file that nodemon can use to kickstart our server again. So we give it the start.js file. And the reason we give it that and not bin www is because www is not a JavaScript file. So we want to give it a JavaScript file that'll kick off the server. And this is that like intermediary that does it. Yeah, you want to be in your main project directory and you want to hit nodemon start.js. Is everyone's server working and updating on its own?
Is the server running? No. You go back. No, I'll tell you.
All right, so how many of you are using Chrome or have Chrome installed? Oh, perfect. If you go to the Chrome App Store or the extension store, there's a cool plugin / extension called Postman. And what this allows you to do is make HTTP requests to an API, even our own API, right from your browser. And it provides a super cool graphical interface where you can save the requests you made in the past, redo them, and get the response. So one thing you'll notice is we've been hitting our API through the browser so far. When you do it through the browser, the only type of request you're making are GET requests, asking the browser to give you something in return. Because we're building an API that will be able to create events, update events, delete events, we need our requests to do more than that. And Postman allows us to do that, allows us to see different headers, cookies that are coming in with requests, and inspect them and make sure everything is accurate and the way we expect. So let's install that. So once you have Postman installed, let's try over here. Actually, I'll just tell you about it first. Here is where you set your HTTP method. So last week we just described the verbs, get, post, put, delete. There's a bunch of other ones too, but here are the ones we need. They are available. So let's try and make sure our API still works again. And here we see the data that comes back. Is everyone good so far? Getting Postman and testing our API through this? Huh?
I have to check the slides.
Sure.
Well, I have some people stuck here.
Okay. Let's help them out.
Yeah.
Who's stuck?
We'll just go around and see.
What's your name? Is anyone stuck on getting NodeMon working and having it refresh your server automatically?
And then post on as well.
And yours? Sweet.
Yes.
Okay. Oh, okay, so see this, it says user. Users, we need to go back into your desktop and be in the same folder that all your so subline text. Okay, start a an app folder. The app folder is in your desktop and in the workshop. So you gotta remember to always bring that folder. Okay, so
that should make a difference.
okay. So I should take
Okay, try it again.
Oh. Okay. You're not working. Okay, now you have to, so CD is changed directly. So we're just adding.
I think it's this. Like I ran. I did this.
So we can't find.
Yeah, when I run, like have a
Whatever you want to do, but you require it. Now, if you take
But I do this.
it's cool as from here, you're able to talk about
Like I don't think I can do anything.
Well, I think so. No, it'll be. Yeah.
You have slides, right? Yeah. Okay, so check this out. We're going to talk about here's creating the errors file. This next slide is where it says your JS
So I installed
Yeah.
Yeah, so we started with this and then
save it and try it again.
What's the error with the like the whole
Oh, you can see it. We deleted all the code that's.
Oh, well, I thought like Express like it's like programming. I thought we took it out. Oh, really?
Second slide.
Okay, all the stuff. Wait, are you still having?
On one of the slides, after we move the error handling, it says your app.js should look like this. And if you'll see there, you'll see there's no view engines and templating. We took it all out.
Oh,
Yeah.
How about you?
Okay.
Oh.
You're good. Okay, so what we can do is after this week,
Oh, it's because we found the error in your yes.
Yes.
And I'll find modules. Wait, so oh, the events. Yeah. So
I don't know if you can run more.
Oh, yeah.
So,
Yeah. I think it automatically looks for .js extension. Well,
Saved it,
yeah, and then just restart it.
and then it just didn't.
Oh, you have like two ones. So you have like a syntax. It says unexpected token.
Okay, so here.
No, it tells you where to look. It says route/events.js. So is it your events?
I mentioned that because we're requiring it, you need to make that call.
Oh, I think you have it wrong. I think it's supposed to be something. So, yeah, function. Yeah. Yeah, that's really hard. But yeah,
Oh, yeah.
This is how it functions.
These error.js exporting a function. You call that function, you pass it into the output. In this case, it's the express. So we'll save this. Now, we'll pass it go back here to save.
Yeah, you're pretty much right.
Now this here. Test applications. Save. That's automatic because, and then we have down between this one right here.
You just copy and paste that line. Yeah.
Same thing that will go
I
3,000.
think it looks right.
Oh my gosh.
Oh, I know why you're doing that view thing. Now,
The title one.
Yeah, yeah, it's
Like
crazy.
that.
Yeah. Just like exactly.
And then all the night cards on here. But I.
Oh, should I say it?
Oh.
yours is good?
Yeah.
I'm gonna head.
And then, oh, yeah, and then just try to.
So now you have the first step is we're going to connect it to it code. We're going to define events.
Oh, you don't have an actual, you didn't define a route for
So we're going to try to do this. So we're going to use an online service called Longboard Lab. If you want to go ahead and follow these ones, just until we get to
because this actually registered route. Because you are getting some yeah, index, yeah, so, yes, that's actually what it did. Yeah, they registered both index, because like they named index as routes, right, so I see routes, and users. Like they just named it differently. It's called index, files called index, but they register as a variable called routes inside this context. Just routes is actually the index file. Yeah. Okay. So I just said that.
It's like full text and then.
Oh, like does it like
No, it's so easy. Or maybe not, no, that was like once. I don't know.
but you should use that to get the already.
No, but I copied them.
All right, so if you guys have been able to get your NodeMon working, restarting your app, the next step, or what we're going to do today, or whatever's left of today, is we're going to set up our MongoDB, our database that's going to store our events. We're going to attempt to connect to the database through our application. Here it says through Mongoose. Mongoose is another package that allows us an interface to MongoDB. It provides a lot of helpers. It makes it really easy to grab the objects, the files, the data you need. Then it's in the slides, but we're going to create the data model for events. So basically a schema for the events. We'll define our API endpoints and implement the endpoints. The first step is creating an account on MongoLab. To save everyone from having to install MongoDB on your own computers, MongoLab will host the database for you and provide you all the credentials you need to access it. So if you want to go ahead and follow the steps over here first, and then we can go on from there. Yeah, right. We're using MongoLab. They host the whole database for you. That's why we're We're gonna fix that. Are you trying to just go look close 3,000? Yep. That would come to try to slash events. I'll tell you why. Okay. So if you're getting an error when you go to localhost 3000 and it says no default view engine specified, that's because in our routes index.js, we cleaned up all the dependencies for viewing and templates, but we didn't remove it from this handler. So if we look back at app, we say anytime someone hits backslash, go to this routes file, which we see comes from routes index. When we look at index, that request handler is telling it to render something. Because we took away all the rendering software, all the rendering paths, when it tries to render it, it doesn't know what engine to use and how to work with it. But what we can do is clear this up. We can just say response.send. So now it'll just send it as a JSON file. And if we go back to Postman and we just look at localhost, we get a JSON object. Has everyone been able to set up their MongoLab database? Yes. So just to clarify, MongoLab is a cloud provider that provides us a database as a service whenever we need it. That saves us from having to set it up, install it, make sure it has room to store data, make sure it has the right ports open on our computer, make sure it's always running when we turn our computer on. For the sake of speed, in this case, we just really want to use something like this. Once you register, make sure you get the verification email. When you're choosing your database name, let's use EventDB. So your code will reflect the code on the slides and just saves us all some hassle. Once you've successfully done it, you'll go back to your homepage on MongoLab and you'll see your database under MongoDB deployments. And once you click on that, it'll give you your connection information, which we're going to use next.
Should you consider like putting this on GitHub like live?
I am tonight.
I mean, like as we do.
As we code.
Like if there's like minor errors, we can just like get the latest repo.
Oh, pull it every time?
Yeah, and just like move forward.
Yeah, I guess they could.
If they're really behind.
Okay, we can do that. Or put the final from what our final project is, our end goal.
Yeah.
Yeah, sure. Or this file over here, their index route. So we changed to this. And the reason we did, we're telling it when we're giving our response, before it was response.render. Since we deleted all the templates, all the views, and in our app.js, when we were doing the cleaning up the house, we deleted viewing engines and we deleted the location of our static folder. And in this line, the reason it was giving an error before is because we told the response to render some output. And we removed all the rendering engines, all the code that tells it how to render, what the types are. So now we just use response.send. Yeah, yep, that's a JSON object, yep. And that's how our iPhones are going to interact with it, how the web apps are going to interact with it, just as simple objects like this. So this is a JSON object, and that means it has a key and a value. And there can be tons of these. Yeah.
Oh, so we're supposed to change the res.render into this?
Yep, response.send. So REQ and RES is request and response. So a request comes into the server, and a response is what you're going to send out.
And my title says express, should I change that?
You can change it whatever you want. Yeah. So has everyone been able to get their database up and running and then create a user to access the database? Yeah. All right, so if we've done that, the next thing we want to do is, now that we have a database, we want to try accessing it. Putting data in, getting data out, and really just creating a connection to the database. So something we're going to use is a piece of software called Mongoose. And Mongoose allows us to connect and query from our MongoDB. And the way we install it is, again, through using Node Package Manager. So when you go to your terminal, before you write npm install Mongoose, you want to make sure we're in the same project directory. So the app folder where we see app.js, errors.js, and so on. The reason we want to make sure we're in that directory is that we're running this npm install without the -g, so it's not installing it globally. It's just a package we need in this project. That's also the same reason we're using the --save argument. And what that does is, after we've run it, shut down. If we go back to our package.json, we see that Mongoose is now here. And the reason that happened is because we said --save. And this shows that anytime someone starts this project and they hit npm install, just how we did at the beginning, all these dependencies are going to download, and now that's going to include Mongoose. So when they start their code, it'll have everything they need to get going, really. Has everyone been able to get Mongoose installed? Over here, npm install. So not the $. The $. Just means terminal command. No, just npm install Mongoose --save. Didn't do anything. Are you in the directory of your project? The CD into your desktop, and then into the. You shouldn't keep going back outside of it. It should just stay. Well, in your terminal, it should stay in the same directory. If you restart your terminal and open it again, it's going to start from like your home directory. But if you just, that's weird. Yeah, I'm not too sure. But if you just CD into it, you'll be. Is everyone good with Mongoose? Yes, no, maybe. I don't. Python problem.
It needs a certain version of Python.
Oh, Mongoose does?
Have the version that's too new.
Really? So if you guys ever want to take a look, the Mongoose documentation is really, really good and helpful for getting started. It talks about defining your schema. So that's something we're going to do next. And over here, they have a schema called blog schema. So I'm guessing it's for a blog post. But we see that they're requiring the package over here, Mongoose. Then from that Mongoose package, they're taking out an object called schema. From there, they're defining a blog schema by calling the new operator. So instantializing an instance of schemas, and they're giving it an object that has the different attributes that a blog post would have and the type. So it's saying title would be a string, author would be a string, body string, comments would have a body and a date, and just some more verbose attributes like here date will be of type date and it'll have a default. So as soon as you create it, it'll automatically have date now, today's date. Some other variables. We're going to do something very similar, but ours is, if you want to get started and do this as well, you can create a file called, do you know what? We'll do it right now. So before we do our model and define our event data model, what we want to do is connect to our database and make sure that works. So the way we do that is by, in our app.js, we want to require the Mongoose package we just installed. And we're going to do that right above our app.use declarations. And in the second command or the second line of code where it says Mongoose connect, we want to pass in the URL that is shown in MongoLab from the MongoLab dashboard.
Did you restart your terminal? Yeah, I know. You know how to add system okay, go to system variables. Yeah, just like search system variables. No, sorry, not internal. Just like search.
So has everyone been able to create a connection to your Mongo database? You want to copy the one from your dashboard. So when you log into MongoLab, is anyone having problems getting a connection? If you don't have a connection, you'll see something like this. So you'll see it crash because we haven't handled the error yet. We'll do that later on, but right now, because nothing's catching it, the whole thing comes running down. Yep.
So two things. One, we copied that from our dashboard, so it'll give us the
Your URL. Yeah.
and then we have to change the username and password to remember our username. So we have to take out those. Yeah.
You want to use that?
Okay, so we just take this out and replace it with that one except our own username and our.
Yeah,
correct.
Yeah. Just type Python. And then just do the nodes and give this all. Control C. It's just like CVF. And then go to your just go back to where stuff like that you did, but so like yeah, yeah. Oh, that's not. Okay. Well, yeah. Oh my gosh.
That's what Mongo Lab is. You create like a database actually in the website.
So yeah, just run the command. Did you see dash?
So I just agree.
Okay, oh, yeah, see, yeah. Do you understand like what game does? Okay, so basically like there's like online whole like packages. And an APM basically what it does is it searches through basically asks that database and looks for the spot like this thing called
It'll crash if it doesn't work.
Oh, yeah, I know, so what do you want?
this saves
Your server restarts.
oh okay, so that is like
Yeah,
the
the
angle one or the dependencies, the NPM dependencies that you have. Yeah, exactly. Yeah.
So to make your connection and make sure it works, this URL connection that we're using over here, you want to go to your Mongo Lab dashboard. So you want to log in. There's a little home button that shows up. And below that, where is it? Here. It shows you your MongoDB deployments. And you'll see a database that you just made called EventsDB. This is still on mongolab.com. Mongolab is going to be the ones that are hosting our MongoDB for us. So once you've found your database and you click it, you'll see a little box on top, which gives you your database connection information. This is personal to you. Everyone's going to have their own connection, their own URL. It's private. So what you're going to do is you're going to copy the second connection URL, and where you see the greater than bracket, DB user, or the square brackets, or not square, triangle brackets, you want to take those out and replace them with your username and your password that you created over here. So you need a database user, which is part of the steps, and then we're going to take the URL from mongolab.com, and that's the URL that gets placed over here. So in my case, I put my username here, and I put my password here.
There's tons of errors in the back.
Is anyone having errors connecting to the database? Before that, great.
Oh.
Just assuming that you can see that. Did you write any more problems?
You gotta let us know if you're having problems.
Yeah.
So is anyone stuck on even before getting Mongoose, just like with MongoLab? Like is everyone at that point or forward? And everyone's created a user on MongoLab, a database user? Cool. And Mongoose, everyone has Mongoose? I just don't want anyone to get left behind because we're all working on this together.
So
Back there? Where are you guys stuck? You can't install Mongoose? Okay. What's it saying? Is it just a stack trace?
First thing in Python, now we need .NET.
Let's see.
I guess these are all things we forget about.
No, it's fine. That's what a workshop is.
I mean, like Python comes pre-installed on Macs.
Oh, they're on Python? Interesting. Okay, so before I help them out, what we can do is if you do have Mongoose installed and you do have a connection, so if you don't have a connection, you'll know because your server will crash. It'll come right down and it'll say, if we look at what comes over here, authentication failed. So if you put in the wrong password, the wrong username, or you're not using the right URL that you got from MongoLab, you'll see this, authentication failed. Because we're not catching that error, our whole server doesn't know what to do. It crashes and shuts down. If you're not getting that, that's a good thing. And then we can move on to the next step, which will be creating a model. So we saw in the Mongoose documentation how they defined a model. So we need to do something similar for our event model. And how we're going to do that is we'll firstly create a folder called models, just so we don't clutter our application code. And in that folder, we'll make a new file. We'll call that event.js. Singular form, it's a single event schema. And to define a schema for a MongoDB model, we will require the Mongoose package again over here. So let's grab that right now. And if you guys look on the slide, the number slide 13, here's an example of the schema we'll be using. So if you can set that up, go help some people out. And finally, and we'll see if it gives you errors later on. But it'll just maybe take a screenshot of that so we can try fixing these errors. See, I think try. Everyone's having this problem. Actually, he did too. Yeah, the option is yeah. So, yeah. You guys, yeah, so far so good. Connecting and whatnot. Yo, you should probably just install this. Yeah. Where did I call it? It's installed now. It's the same one. Yeah. Oh, you know what? Just it's optional. Just keep going ahead. Which had you already do?
So here's the NPM install. That's just one of those basic express on the file. And that's where I'm going to post my product up today. So I have this copy. So
Let's continue building our event schema. So in the event.js file in our models folder, we've required Mongoose. And as you can see, Mongoose can connect to a database, but now we need to define a model, a schema that models an object or models something. So we need to get out the schema object from Mongoose that'll allow us to make this definition. So we're going to go like this. And do you guys understand dot notation, right? When you say mongoose dot schema, it's going to the mongoose package, and then it's going one layer down and saying, do you have a property called schema? In this case, the property is an object that we're storing to a variable. If you're unfamiliar with some JavaScript syntax, we posted a link earlier in the Facebook group and on the event page, which has some introductory material into JavaScript, because it does have some weird quirks in the language. Dot notation is pretty common, but as we move forward with callbacks and the asynchronous aspect of Node, you might want to understand it a little bit better. You don't have to be an expert on it, but just have an understanding why we're doing certain things. I think we said like the first 4, just variables, objects, functions. Yeah. Okay, so here we're grabbing schema from the Mongoose package. Next, we want to define our event schema. So we'll be doing exactly what it says over here. I'm going to make that bigger next week because I can't even see it. Let's, how do you? So we'll say event schema equals new schema. So if you guys have done programming before, you know that the new operator, when given a class, it will create a new instance of that class. So if we think about it, we took off the schema from Mongoose, and now we want to create a new instance of a schema, which will be our event schema. But now we want to pass in some information about our event and what we want this to have in the data model. So we want our event to have a name, which will be a string, date, will be a date, and a description. And that'll be a string. And now we've defined our event schema. For us to be able to use the schema anywhere, we need to first link the schema to Mongoose. So right now, Mongoose is operating on its own over here. We've taken out this, you can think of it as a blueprint. When we say mongoose.schema, we've taken a blueprint for a schema that Mongo will understand when we give it back to it. So we've taken this schema, we've created our schema for events, but now we want to notify Mongoose that we've created this and that it exists with these data types. The way to do that is by defining or writing this in. Mongoose.model, give it a name, and give it the schema. So now Mongoose, because in our app.js file we created a connection, Mongoose is connected to the database. When we say mongoose.model, it's going to register our event schema to this model called event. And what we'll do is, because we want to do things with our events, we want to create them, read them, update them, delete them, we need the schema to be available to us. We want to access it from across our application. And as we did before, we want to export this out so that when you require models event.js, there is a model that that Mongoose understands and knows exist. So we'll do module.exports, and we'll export this new model that's being connected. Does that make sense to you guys, or should I expand on anything more on how this works and operates? If you have any questions, please ask. It's easier that way. Okay. So do you know about databases, how they have a schema? They have different types you put in, or different fields and attributes, and each attribute has a data type attached to it. So a password might be only a string or only numbers, or a phone number is strictly numbers. Here we're defining our event schema to have an attribute called name, which is a string, an attribute called date, which is a date object, and an attribute called description, which is also a string. So we've defined this as our event schema. And what we need to do next is we need to tell MongoDB about it. Our database needs to know what the schema is and that it exists. So the way we do that is we call mongoose.model. Model is a function of the Mongoose package that takes in a model's name. So we've named our model event, and it takes in the schema of that model. So now we've defined a schema. So here on line 10, we give the model a name and we tell it what schema this model will follow. And that's what's happening on this file. If there's any confusion in Mongoose later on, the documentation is really good. They've been working on it for years. So you can always check out there. They have tutorials and examples on how to access your models, how to query them, how to do some advanced queries on them. It's all in there. And the reason we do module.exports is because we've now created this file called event.js, which has this model called event. We want to access data from this model at different points in our application. So we export it. And by exporting it, we can go to our routes file, like events, and we'll do something like this. You can go var event model equals require dot. One thing we're going to do here is dot /. And what that means is move back a directory. So if you notice, this events file is in the routes folder, and we want to require a file that's in the models folder. So if you imagine there's a little magnifying glass and it starts where you are now, we need to move the magnifying glass looking for the file back a folder first, and then we can go. So imagine it's here where the mouse is. We want to go back outside this folder, then go up to models, and then inside the event.js. So this is just saying go back, and then we say models, event.js, save. And we can make sure we did it correctly because no errors have come. If we were to go the old way we did it, app will crash because it cannot find that file that we've told it to require. So we kind of jumped ahead a bit by requiring the event model in the events router, but we will need this later on. Is everyone okay so far? Is anyone's server crashing or connection's not working? Cool. So our next step is to define some API endpoints. So we keep mentioning this. This is one of the important parts. So we have the three components of our full stack application by the end of this whole workshop series. One of them is the mobile app, one of them is the web app, and the other is the server. The server is going to provide data to the two other applications. It's the main centerpiece that glues it all together. So we've just defined our event model. We've connected it to MongoDB using Mongoose. We've told it what the data types are, what the attributes are, and now we realize that we have this event, but it needs to be able to be created. We need to be able to create events using the schema we defined. We need to be able to read events. And the way we're going to do that is by defining HTTP endpoints. If you remember when we were using Postman, we were setting those HTTP verbs. We set get, telling it we need to get data from the server, but now we want to set some other ones like put. We want to put an event in the database. We want to delete an event from the database, post an event to the database. So we're going to map these verbs, these HTTP verbs, to the respective functions, which are create, read, update, and delete. And just to recap, because what we've done with our code base, we can do it a very simple way. So a lot of tutorials and workshops do it in one big app.js file. And I just don't think that's super helpful, because when you go to develop your own applications, no one makes an 800-line file. It's just not realistic. So we have broken things out. Like we have a routes folder now and a models folder. And it's a little confusing. I know some people might require the wrong file name, or it might not work right off the bat, but in the long run, it is better. The modularity is an important part of software design. So we're trying to implement it in a small part here right now. So just to recap what we did last week, in our routes file, the events.js, in our routes folder, events.js, we should have something like this. Right now, we just added, over here, we added the new event model that we required. And in our app.js, we required that whole router we built. That's over here. We required this router on this line. And we told Express, anytime a request comes into the server and it's saying get localhost port 3000 / events, send it to here. Send it to this router to handle it. So that's why when we go localhost 3000 / events, we can imagine a request comes in, it hits this point over here, Express sees a match. It sees, okay, / events, let's send it to this router. When it comes to that router, which is over here, it's top file or a top piece of code, it comes down and then it tries to get matched again. Here we see / means just the root index. So it matches, it's a hit. And then this request handler gets called. Request handler is called and we're saying response.send events. That means whoever made the request now has a response coming to them with the text events. Does that make sense for how Express is going to take a request, decide where it goes, and who's going to give it an answer, who's going to reply to that request? We're going to see this a lot, function, request, response. Next, like we mentioned earlier, these are the handlers that handle incoming requests to the server. Over here, we're just going to talk a little bit more about how Express does it. We see app.use declared 3 times. And what app.use is, it's a function that takes a path and it takes a router. Over here, it's a function that is a router. Express sends all the requests that match a path to the router defined. As an example, if we were to say app.use /Apple and maybe have an Apple's router, any requests like these, like back /Apple, /Apple, /images, and so on and so forth, would all go to the router defined. It catches them all. Is that clear for everyone? How that would work? In our events.js file, in the routes folder, we've defined a router. Here in the code, we see we're grabbing the Express module, we're requiring it, and then we're telling it, hey, we need to grab a router from you. So that's what this is doing over here. It's telling it we need a basic router. And then using that router, we want to define routes. Routes are different API endpoints that allow other applications like your iOS app or your web app to interface with the server. So we first defined a route and we told it router.get. If you remember when we were using Postman, we told it get localhost port 3000 /events. By using the get command or the get HTTP verb, it knows that Express can skip or the router can skip any of these handlers that aren't get. So a get comes in, it's like, all right, we can look at the get handlers. Then we can match the path. And then we can give a response. So that's what's happening over here. As we'll see, it's defined like this: router dot HTTP verb, the path that we want to handle, and the function that we want to call. And the reason we export this is, again, for modularity. So we can define all the routes for a certain model in one place, in one file. And that's what we're going to do today. So this events file will have \get events, get event with a certain ID, delete an event, update an event, and they'll all be in this router. This router is going to define all the routes we need. And we've already exported it, and we'll see that we've required it again over here in our main server file. We say, hey, let's get all the event routes, and then we'll tell our application, anytime it sees /events, use the routes we've defined in the other file. Does that make sense to you guys? I think next week we can do another house cleaning and rename some files, because it's even confusing for me right now. But is everyone clear with how that works and how a request is going to come in? Okay. So for basic functionality, these are the endpoints we are going to make. I talked a lot about CRUD and verbs, and it's kind of hard just to get it plain old because it doesn't make sense. It doesn't have any context, at least. So here it shows what the function is we want our server to do or be able to handle, what the CRUD functionality is, whether it's creating data on our server or in our database, or reading data from the database, updating and deleting, and what the verb we'll be using is for that. And here is the endpoint. Imagine all of these were prefaced. Every endpoint was prefaced with localhost port 3000 / endpoint, 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 endpoint. So we'll talk about each one. The first one is creating an event. When we create an event, we want to push data into the server. We want to say, hey, the event is going to have this name. It's going to have this description. It'll be on this date. We want to post it there and say, hey, you guys should store it in the database. In respect to CRUD, this is a create. We're creating data. on the server, and we're going to use the endpoint /events. What you'll notice is a lot of these different functionalities share the same endpoints. We can get all the events from row 2, or we can create an event both using /events. But the difference here is that the verb we're choosing to use in our request. One is going to say post to /events, and the other one will say get /events. When we want to get a single event, it's a little bit different. We'll be using the verb get HTTP verb. We'll be reading again from the database, but now we'll be saying, let's get data from /events / the event ID. This allows us to uniquely identify a single event on the database. It's very similar to the updating of an event. In singular form, we want to update one event, so we'll have to pass in its event ID. When we're updating, we're going to use the put verb. We're going to be putting more data or putting data into the database. It's kind of confusing because put and post, you think they're the same, but what we're doing right now is we're defining what's called a RESTful API, and that stands for representational state transfer. And what it means is that the database holds a state. Everything is an object that has a state. So we're going to get the state of back /events. We'll get them all. We'll get the state of events / an event ID. It's getting a single event. Put, we're going to be putting data in. Delete, we're going to be deleting data. All these verbs, I can post some resources to better understand how to design a RESTful API. This is a very basic one. Next week, we're going to add the search functionality, and you'll see a way where our search criteria will be right in the endpoint. We're going to add a question mark in there, and that can take in data too. It'll be question mark, maybe name equals something. Part of RESTful design is to have all your endpoints be reflective of a model that exists in the database. So events is a model we have. So we're going to create an endpoint that they all start with /events. And that makes it easy to map the create, read, update, delete to actual API endpoints that a server can respond to. Is that clear for everyone? How it works and why we do it, just the understanding between the two? Cool. So this is the fun part. We're going to make our first API endpoint that will allow us to create an event in our database. So let's look at the code first before we actually start typing it in. What we're doing is we've said that over here, when we create an event, we want it to we want our handler that creates the event to only respond to post requests that come in and post requests that come into the /events endpoint. So when we look over here, similar to how we've already defined our routes, we see router.post, which tells it, okay, this handler and this path will be handling any post request that comes in. Something that's kind of confusing and tricky the way the router works is you'll notice it's a / over here. We've told it the path is /. But over here, we've said we wanted our endpoint to be /events. And the reason it is this way is if we go back to our app.js file and we see the events router we're working with, we've already told it that anything that has /events will be going here. That means when we go to our events router, it's only getting requests that are being sent to the endpoint with / events. That's why we use just a single /. That means nothing else exists. If we wanted to create a post route over here for events / information, that's how we would do it. And this would say, this would be get or post local host 3000 / events / information. Does that make sense to you guys? It's a little bit confusing why we wouldn't put events over here like that. And the only reason is we've already done it here, just to segment it off, keep our code clean. That way here, every handler is not going to have / events, because that's duplicate code. That's more code to maintain. We're going to try and avoid that. So let's go ahead and create the first API endpoint. Which is here. If you guys have the code or the slides, you can go ahead and copy that into your routes events.js file. I'll do the same. If you guys haven't started yet, maybe we can talk about it first, so it makes sense what you're copying in. That's where we're going to go. So back to describing what this code does. We've told our router it's going to be accepting a post request at /. In this case, this whole router is accepting the / events endpoint. So it's already coming in for / events. Those requests are already arriving at this request handler. Now what we want to do is, because we've imported the event model into our events.js file, sorry, I'll have to rename this just so it matches the example in the slides. We've created this variable over here, which holds our event model. The model that MongoDB knows exists, the model that has a schema, it's what we're going to be using to store our data. So here, we tell it, let's create a new event using that schema we've defined, using that model we just required. So we call new event again. If we imagine this model is like a blueprint that we can start building from. And using the new keyword, that's how we'll set a foundation to build this. So we created a new event, store into the variable new event. And over here, we're going to set the event's name, date, and description. Over here, you'll see where we're getting the data from. Event.name equals request.body.name. So something interesting about post HTTP request is that when you post something to the server, you can attach data to it. It's not in the URL. You can send additional data to a server. So what we'll do is, let's try posting something. We go post. Notice how when we have get, this body selection is dulled out. It's not clickable. But when we go post, we can now add a body to the request. So let's do a simple route to see what comes back when we post data. So let's post data to here. And in our console, we're just going to log the data coming out. Let's stop body. Sorry. We're going to log the body parameters that are being sent up with the post request. You don't have to worry about copying this part out. This is just to understand how data is being transferred. So now we'll be doing a post to the events endpoint. And let's just pass in some values. So we'll say value 1 has some value, value 2, another value. And let's send it. And request.body. Oh, sorry. One thing we're going to do is, my mistake, we're going to set this to www form URL encoded. The reason we do that is that's just so our server knows where to look for the body, and we're telling Postman where to put the body of data. In our app.js file, we told it the body parser. We said app.use body parser URL encoded. We tell it, hey, the body is going to come in from the URL encoded part of the request. Let's go back here, save that. Say here, value 1, some value, value 2, another value, and we'll hit send. And we see that our server, it got the request, and these are the values that came in. And the way we did that, the way we accessed it, is in our in our request handler, using the request object that comes in, we told, or we accessed the body variables or the body data just using request.body. If you want to see what comes in with the request, say we were to do this again, a ton of data comes in saying, let's see, here it shows who sent the request. It came in from an Intel Mac. It came in with URL encoded data. It came from a Chrome extension. We can see a lot. This all comes in as part of our request, but most times we don't need it. Here it tells us which method came in, what URL. Let's see. So let's not look at that anymore. Don't want to confuse you guys. Okay, so now we know how data will come to the server. It comes in through the request.body object. So if you've used JavaScript or JSON before, the way to access these parameters that have been received, so we'll go back to console.log, request.body. If we want to access this value 1 that just came in, you see the curly braces over here? The curly braces means that it's a JSON object. That's the notation they use to define an object. It has curly braces. There's a key, which you can say is value 1 and some value. We call these key value pairs. And a dictionary or a JSON object, it could be one or many or none key value pairs. Go back here and say we want to access value 1. We want to be able to use this value somewhere. All we have to do is say value 1. So now if we send a request, it should only print out the first value, which in this case is some value. That's again just object notation from JavaScript. Any simple like beginner intro to JavaScript will teach you guys that. If you are having troubles, just take a couple minutes and read up about it. You'll find this in a lot of other programming languages too. Okay, so back to here. What we do is we've set up our blueprint for what's going to be an event. We've said this new event will have a name that'll come in from the request body using the attribute name or the key name. It'll have a date that comes in from the request body, and the same thing with the description. The next part we're going to do is we're going to save this new instance of an event. We have a blueprint. We've given it, the doors, the roof. We've created something. Let's save it, right? So we call the save function on the blueprint. So new event.save. What you'll notice is, the save method or function has a parentheses here, a parentheses here, but there's a whole function in the middle. And this is part of JavaScript's and Node's asynchronous design. We mentioned last week, Node is different than other app servers in that when a request comes in, it doesn't have its own dedicated thread to answer it. There's a big event loop which takes a request in all the time. It keeps spinning and spinning. And this is what makes Node really, really fast in handling requests. If something's going to take long to, say you have a database query that takes 10 seconds, you don't want every other request to wait 10 seconds for room for it to be responded to. In this case, that's why Node has a lot of callbacks. Callback means you tell it what to do, and when it's done doing that, it'll call back and it'll give you the result you're looking for. In this case, we call save and we give it a callback function that takes an error or that accepts an error or the new event we've saved. So if this function were to take 10 seconds to return or call itself back, our server would run A-OK and other requests would be served. When this function is called, if an error happens on the database, it'll be returned and we'll see it. And if everything works out fine, this saved event parameter will have the new event that we've just created. Here we say if error, let's return next error. And we remember, if you guys remember from before, we said by calling next with an error, it passes it down the stack. So it passes it to the next handler. So since no other handler is going to meet /events, it's going to be one of those error handlers that we defined earlier. And in this case, we hope nothing, there's no errors happening. In that case, we're going to send a response back to the client with our new event. So as you'll see, we're not really playing with any data types that Mongo's giving us back. We're just sending it. And the reason we do that is MongoDB is all in JavaScript object notation, which is JSON, which are these JSON objects we've been dealing with. Everyone works the same, so the data just crosses over throughout the stack very easily. But I think we can go and implement this next week. Are you guys cool with that? The slides are up. What I'm going to do is I'm going to post the full working code on GitHub with all the routes implemented if you want to take a look and check back. We'll post the link to the repository on the group, but I hope this is better than last week and it helps.
I'm slurping. I didn't eat all day. Oh, lava pizza. You had lava? Oh my god. I might need lava.
I gotta go finish